p62, a couple more examples here. One's called separating the numerator, which I think is pretty self-explanatory. So, first step, separate the numerator. All right, so once you do that, you're on your own. No, well, you're going to be relying on some rules, all right, so, or techniques. The second one, the second integral, is a rule, and you might recognize that up above. You see inverse sine as a derivative. That's 1 over the square root of 1 minus u squared times du dx. All right, so this follows that form. All right, so the other one, I'm looking at the radicand on the bottom. I mean, aside from getting into trig substitutions and things like that, which is doable and possible with a question like this because it follows that mold also, you look at this and say, well, what is the derivative of that radicand? Because this might be a u substitution case. 1 minus x squared has a derivative of negative 2x. If I solve that for x dx, because that's all I really need, I'd get negative 1/2 du is equal to x dx, in which case I'd be looking at negative 1/2 du, or quality u, over the square root of just a u, which I could rewrite as negative 1/2 u to the negative 1/2 du, which would anti-differentiate, oh, put the emphasis on the wrong syllable there, to u to the 1/2 divided by the new exponent, and you get a negative 1. So we'd have that part. This part is the inverse sine of x. So put it all together, making sure that you reverse your substitution. U is really 1 minus x squared. And you'd have an antiderivative of negative 1 minus x squared to the 1/2 plus inverse sine of x plus c. All right, so, you know, it takes a little doing, a lot of writing. I color code a lot, but it gets you there. Now, the last one on this page, disguised log rule, that doesn't really tell you anything except that perhaps a logarithm would be involved, which I guess kind of does tell you something, because if a log's involved, and usually we look for the numerator being the derivative of the denominator, that's telling me that I should have an e to the x in the top of the fraction here. So that's what I'm going to do. I'm going to put an e to the x in the top of the fraction here. We have a precedent for this. You did it on the previous page. So I'm going to add an e to the x. If I add an e to the x, I can't just do that because I want to, so I'm going to subtract an e to the x. And then I'll split my fraction. I'll have a 1 plus e to the x over 1 plus e to the x. And then a negative e to the x over 1 plus e to the x. All dx. So integral of 1 minus all this other stuff. Antiderivative of 1 is x minus the derivative of 1 plus e to the x is e to the x. So that means that this is following the natural log mold. So ln of 1 plus e to the x will do the trick there, plus the c.